Hi everyone! In today's video, we'll be talking about how to find trig ratios given another. Here's today's FLT. Given a trig ratio, I will be able to find another trig ratio in simplest radical form. In the previous lesson, we learned about the 6 different trig ratios. Today, we're going to be given one trig ratio and find the remaining 5. Here's a quick reminder that the adjacent and opposite sides change depending on where you're standing from. And the hypotenuse is always across the right angle. So be careful about these when you're identifying sides. So before we look at some examples, let's review the 6 trig ratios. Look at your notes from earlier if you need to, and write out the 6 different trig ratios. Press play when you're ready. So here are the 6 trig ratios. In the top row, we have the sine, cosine, and tangent functions, and the bottom 3 are the reciprocal functions. So we have the cosecant, secant, and cotangent functions. So for example, cosecant of theta is the reciprocal of sine of theta. So please make sure you have these written somewhere in your notes, and let's move on to some examples. Here's our first example. Given one trig ratio, find the remaining trig ratios. So here, we're given that sine of A equals 3/5, and we're going to use this to find the 5 remaining trig ratios. We know that sine of theta is the opposite side over the hypotenuse. So we know that this 3 represents the length of the opposite side, and the 5 represents the length of the hypotenuse. So with this information, let's create a triangle. It doesn't have to be drawn to scale. And let's set our point A. From here, let's identify our 3 sides: the opposite side, the adjacent side, and the hypotenuse. Here's the opposite side of angle A. And we have the adjacent side, the side right next to angle A. And the hypotenuse is always right across the right angle. So we've identified our 3 sides. And we also know the opposite side length is 3. And the hypotenuse side length is 5. But what about the side length of the adjacent side? What idea can we use to find the length of a missing side when we're given 2 sides of a right triangle? The Pythagorean theorem. So we have a squared plus b squared equals c squared. We don't know what a is, but let's set b equal to 3 and c equal to 5. We're going to simplify to solve for a. And I know I'm going kind of quick right here, but please let me know if you have any questions about the steps. So we solve that a equals 4. So the length of the adjacent side is 4. So we have the side lengths of all 3 sides. Now we can go back to set up our remaining 5 trig ratios. So for cosine of A, I know it's the adjacent side over the hypotenuse, and the adjacent side is 4, the hypotenuse is 5, so 4/5. For tangent of A, it's the opposite side over the adjacent side, so 3/4. Cosecant of A is just the reciprocal of sine of A, 5/3. Secant of A is just the reciprocal of cosine of A, 5/4. And cotangent of A is the reciprocal of tangent of A, so 4/3. So we were able to find the 5 remaining trig ratios when given just one trig ratio. Here, we first set up a triangle and found missing sides using the Pythagorean theorem. And once we knew all three side lengths of the triangle, we were able to set up our trig ratios. Let's look at another example here. In this example, we're given that the cosine of b is radical 21 over 5. The cosine of b is the adjacent side over the hypotenuse. So with this information, we can set up a triangle. I could have set up the triangle like earlier, that would have totally been fine, but I kind of wanted to show more variation here. So here's the opposite side of angle B. We have the adjacent side right next to angle B. And lastly, the hypotenuse. This one is always across from the right angle. We're given that the adjacent side is radical 21 and the hypotenuse is 5. But what about the opposite side? Let's use the Pythagorean theorem to find out. We have a squared plus b squared equals c squared. And a is going to be our unknown value. B is radical 21. And c, our hypotenuse length, is 5. This simplifies to a squared plus 21 equals 25. Subtract 21 from both sides, and a squared equals 4. Take the square root of both sides, and a equals 2. So the opposite side length here is 2. So now we have all three side lengths, so we can set up our remaining trig ratios. Sine of b is the opposite side over the hypotenuse, so it's 2 over 5. Tangent of b is the opposite side over the adjacent side, so 2 over radical 21. Remember, we want to rationalize the denominator, so we have 2 times radical 21 over 21. Cosecant of b is just the reciprocal of sine of b. And secant of b is the reciprocal of cosine of b. We have to rationalize the denominator, so 5 times radical 21 over 21. Lastly, cotangent of b is the reciprocal of tangent of b. And let's just focus on this one. The reciprocal is simply radical 21 over 2. So we were able to find the 5 remaining trig ratios when given cosine of b. Whenever you see radicals, make sure you're rationalizing the denominator when needed. Let's look at one more example. Here we're given that the cosecant of angle E equals 17 over 14. We know that the cosecant of E is the hypotenuse over the opposite side. So try setting up your triangle on your own and find the missing side. Press play when you're ready. Your triangle might look a little different compared to this one, but the idea is still the same. So here, the opposite side is right here. And we have the adjacent side. And lastly, the hypotenuse. We're given that the hypotenuse is 17 and the opposite side is 14. But what about the adjacent side? Once again, let's use the Pythagorean theorem to solve for the missing side length. I'm going to set b equal to 14 and c equal to 17. I have a squared plus 14 squared, that's going to be 196. And then 17 squared is 289. Let's subtract 196 from both sides. This cancels out. We have a squared equals 93. I take the square root to get a equal to radical 93. We can't simplify this, so let's just leave this as is. Radical 93. Now we can find the 5 remaining trig ratios. I know that sine of e is just the reciprocal of cosecant of e, so it's 14 over 17. Cosine of e is the adjacent side, radical 93, over the hypotenuse, 17. Tangent of e is the opposite side over the adjacent side. So that's going to be 14 over radical 93. And make sure to rationalize the denominator. 14 times radical 93 over 93. Secant of e is the reciprocal of cosine of e. So that's 17 over radical 93. It's 17 times radical 93 over 93. And lastly, the cotangent of e is the reciprocal of tangent of e. So radical 93 over 14. Here, we were given cosecant of e, and we found the 5 remaining trig ratios. So here's a quick review for today. We've looked at 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. The functions are reciprocals of each other. So sine and cosecant, cosine and secant, and tangent and cotangent are reciprocal pairs. When given one trig ratio, use that to help you identify the opposite side, adjacent side, and hypotenuse. In these examples, we use the Pythagorean theorem to find any missing side lengths. After that, we were able to set up our remaining trig ratios. Awesome job today, and please remember to submit your notes on Canvas.